If instead of an alkyl halide, had we used another series of compounds called acyl halides, then we have a slight variation of Friedel Crafts alkylation, which is called Friedel Crafts acylation. What is an acyl halide? Have you seen this before? So we have a carboxylic acid here, and if in the carboxylic acid, if we replace the OH part by a halogen, then this whole compound, it is called an acyl halide or an acid halide. So let us get back to the reaction. So we have the benzene ring and we have an acyl halide and a suitable anhydrous AlCl3, which is the Lewis acid, and we have the products. So we have the substrate here, and what have we here? On either side of the arrows, we have the reagents. We have the acyl halide and the Lewis acid, and we have the final product. What would be the mechanism for this reaction? If you observe, AlCl3 does what it always does best. It removes the halide or chloride ion from the reagent, and this becomes a really powerful electrophile. So this electrophile is the acylium ion, and if you look at the structure of this electrophile, it's pretty interesting. This carbon will be sp hybridized, and so this electrophile, it attacks the benzene ring. Again, we have the laws of aromaticity. So this intermediate is going to be non-aromatic, and the formation of this intermediate is going to be the slowest rate determining step. And immediately after this particular step, the RDS, deprotonation happens. Now, what can you say about the pace or the rate of the deprotonation step? It has to be pretty fast, right? So immediately after the deprotonation, the aromaticity of this ring, it is re-established, and the product is said to be acylated. If you look at the products, so we have the benzene ring and we have a single bond carbonyl group, and the carbon on the other side is bonded to an alkyl group. Now, can we move from this acylated benzene ring into an alkane? Very well. There is something called a reduction reaction. So you take the acylated product, you reduce it, and you get the alkane.